to Unit 4, Part 2. We are talking about the greatest common factor, or as you probably remember it, the GCF in this section. Again, probably review, hopefully review, but also pretty difficult concept of time to make sure you're taking good notes. A couple of definitions for you when we're finding the greatest common factor. A common factor is a whole number that is a factor of two or more non-zero whole numbers. So factors that two or more numbers share. And then they put a definition for a greatest common factor. It's pretty much the worst definition ever because it's just the greatest of the common factors. So all it does is add two words to what it is. But again, as we go through it, you'll have a better understanding. So first thing, we're going to get right into it and find the greatest common factor of the numbers. In order to do this, we need to find the prime factorization first, which we talked about in the last section, which means I need to do factor trees for both of these. So 8 is going to split into 2 and 4. 2 is a prime number, so I circle it. 4 breaks into 2 and 2, so I circle both of those. For 24, that's going to split into 8 and 3. 3 is a prime number, so we circle it. 8 breaks into 4 and 2. 2 is prime, so we circle it. 4 breaks into 2 and 2, so we circle those. Now to find the greatest common factor, we're going to want to write those out. So for 8, I had 2 times 2 times 2, and for 24, I had 2 times 2 times 2 times 3. Next step is to circle the ones that are in common. So this 2 is in common, this 2, and this 2. So our greatest common factor is going to be 2 times 2 times 2, which is 8. So the GCF will be 8. I'm going to let you guys go ahead and do number 2. I'm going to skip down to number 3. If you look at number 3, we now have 3 numbers that we want to find the greatest common factor of. So a little bit more work, but still the same concept. So 16, I'm going to split that into 4 and 4. And both of those 4s can be split into 2 and 2. And 2 is a prime number, so I can circle all of those. Next up, I have 32. I'm going to split that into 4 and 8 to start with. 4 splits into 2 and 2, both of those are prime. 8 splits into 2 and 4. 4 splits into 2 and 2. And then for 40, I'm going to split that into 4 and 10. 4 will split into 2 and 2, those are prime. 10 will split into 5 and 2, those are prime. Now, I'm going to go ahead and work into the next one just because I'm going to run out of room. So for 16, I have 2 times 2 times 2 times 2. For 32, I have 5 2s. And then for 40, I have 3 2s and 5. Now, our next step is to circle the numbers that are in common. When you have 3 factors, or 3 numbers, you have 4 numbers, we're doing various common factors, they all have to share that number. So they all have this 2, they all have this 2, and they all have this 2. Now, 16 and 32 share another 2, but all 3 numbers have to share it. So our greatest common factor would be 2 times 2 times 2, which is 8. So the greatest common factor for that one is also 8. Alright, so important thing to remember, if you have more than 2 numbers, they all have to share a factor for the greatest common factor. Alright, working our way down, the next thing we're going to look at is identifying relatively prime numbers. Numbers are relatively prime if the GCF is 1, so if the greatest common factor is 1. So for the bottom 2, all we're going to do is tell whether or not they are relatively prime. So I'm going to leave number 1 for you. I'm going to come over here and do number 2. So I need to do factor trees for both of these. So 22 splits into 11 and 2. Both of those are prime, so I can circle them. 35 splits into 7 and 5. Both of those are prime, so I can circle them. If you look, okay, 22 and 35 do not have any factors in common, which means their only factor in common is 1. So yes, these are relatively prime. Their GCF is 1, which we don't even write on there. So 2 I'll leave for you guys to figure out if that's relatively prime or not. Looking at the backside, okay, now we're going to find the greatest common factor of monomials. So again, same process that we've been doing. This makes it a little bit more difficult because we have variables in there. But to start with, we need to find or do the prime factorization of our number. So 32 is going to split into 16 and 2. 2 is prime, so I circle it. 16 splits into 4 and 4. Both of those split into 2 and 2. So that's the factor tree for 32. Factor tree for 20, it splits into 4 and 5. 5 is prime. 4 splits into 2 and 2. Those are prime. So again, I'm going to come work over to this extra space to run out of room. So 32xy is going to break into 4 2's, an x, and a y. 20y to the second is going to split into 2 2's, a 5, and 2 y's. So now we circle what they have in common. So they have a 2 in common, they have another 2 in common, and they have a y in common. So the greatest common factor is going to be 2 times 2 times y, which is 4y. So that's our greatest common factor there. So if you notice, they both had a y in common, but since we're doing greatest common factor, we took the lower exponent, which is y first. That didn't make any sense, don't worry about it. 2 and 3, I'm going to leave for you. I'm going to come over here and do number 4. So again, we'll start with the factor tree. So 9 is going to split into 3 and 3. The prime 18 is going to split into 9 and 2. 2 is prime. 9 splits into 3 and 3, which are both prime. And then 6 is going to split into 3 and 2, which are both prime. So again, coming over here just because I don't have a lot of room, 9x y squared is going to be 3 times 3 times x times y times y. 18y to the third is going to be 2 times 3 times 3 times 3y. And then 6x is going to be 2 times 3 times x. So if you look, we have a lot going on, but what we need is what all three of them have in common. And the only thing that all three of them have in common is a 3. Okay? So again, sharing between two of them isn't enough when you're doing greatest common factor. They all three have to share it. In this case, the only thing they share is a 3. So that would be our greatest common factor. All right, moving on to the bottom. It says simplifying a variable expression. Okay, this can get kind of confusing, but if you lay everything out, it's really not going to be all that difficult. Okay? So let's look at number 1. It says to write the fraction in simplest form. To do this, we're going to want to start with our factor tree. And again, because of the lack of space, I'm going to come over here to do my factor tree. So 60 goes into 12 and 5. 12 will be 4 and 3. 4 will be 2 and 2. And then I have all prime numbers there. 40 is going to split into 10 and 4. 10 is going to split into 5 and 2. 4 is going to split into 2 and 2. So now I'm going to write out my factors on the top and the bottom. So for the top, 60 is going to turn into 2 times 2 times 3 times 5. And then I also have 3 x's and a y. And then on the bottom, 40 is going to break into 2 times 2 times 2 times 5. And then I have 2 x's and 2 y's. Now when I'm simplifying, I'm just going to cross out everything they have in common. So they have that 2 in common, they have this 2 in common, they have 5 in common, they have 2 x's in common, and they have 1 y in common. And then I just write what I'm left with. So on the top, I have 3 and x left over. On the bottom, I have 2 and y. And then I'm done there. That's the simplified version. Number 2, I'm going to leave for you. I'm going to come down here and do number 3. So for number 3, again, I'm going to start with factor trees. I'm going to come over here for space. 63 breaks into 9 and 7. 7 is prime. 9 breaks into 3 and 3. Both of those are prime. 25 breaks into 5 and 5. Both of those are prime. So now you go ahead and write out what I have. So on the top, I have 3 times 3 times 7. And then I have 4 B's and an R. And then on the bottom, I have 5 times 5, and then I have 2 R's. Now I'm going to cross out what they have in common. They don't have any numbers in common. The top has B's, but the bottom doesn't. So all they have in common out of all of that is just 1 R. So that means I'm going to be left with, I'm still going to have 63 on top because I didn't get rid of any of the numbers. I'm still going to have all 4 B's. On the bottom, I have 25 and I have 1 R left. So from all of that, all we canceled out was 1 of the R's. Okay, so 2 and 4 are left for you. Do your best. If you have trouble with them, you can ask me during class. That's it, part 2.